So the title of the talk, as you can see, is Extending Parametric Comparison, Some Preliminary Results. And so we're just going to talk about the project that George mentioned in the introduction that Jim and I have been working on since September last year. And the goal of the project, if I can scroll, okay, let me try this. Sometimes with screen share, it can be very difficult to scroll. I don't know if you've noticed that. I can't move this. Hang on, let me stop the share for a second and go back. Let's try it this way. The goal of the project, try it like this now. Oh, no, I won't. Sorry, let's just keep it like that. The goal of the project is to develop a database of parameter values in the form of a parametric grid of the kind that's familiar from work on nominal parameters by Pino Longobardi and his associates, which they've been doing now for about 20 years. We are investigating 87 clausal parameters in 42 languages. And this will ultimately combine with the database that Longobardi and his associates in recent papers have put together. They have now a total of 94 nominal parameters for about 58 languages. So combining the two databases will give us something extremely significant, we believe, and should be a resource for the field in general. Just for those of you who aren't fully familiar with the parametric comparison method as it's been developed by Longobardi and others in recent years. Basically, the idea is to construct a table of this kind, which gives information about, first of all, a parameter and a code associated with the parameter. And then there can be an indication of the implicational relations that that parameter bears to others. So, for example, here, parameter 2, plus or minus grammaticalization of person, depends on the positive value of plus or minus grammatical morphology in order to be active. And then we can look across languages and construct the database by setting the parameter to one of three values, plus, minus, or 0. 0 is when the parameter has been switched off owing to an implicational relation with some antecedent parameter. And so here we have a few, this is just a very small part of table A, giving the first 20 parameters and their values in about, 6 or 7 languages. Here we have Sicilian, Italian, Spanish, French, Portuguese, Romanian, and Greek. So that's the kind of thing that we are aiming at constructing for clausal parameters. This then leads to the possibility of calculating distances between grammatical systems. This can be done in terms of defining a quantity delta, which is determined by the equation I over I plus D, where I stands for the number of identities in parameter values and D stands for the number of differences. We're then able to apply phylogenetic software of the kind that has been developed mainly in evolutionary biology to produce the optimum tree representing the syntactic distances between each pair of languages in the sample. So the next slide here shows the parametric distances between, shows a tree, produced by the Klck program, which is one of these phylogenetic programs, for a range of languages. And you can see that the tree, up to a point, with certain provisos, very closely reproduces trees that would be the result of the traditional methods of comparative reconstruction. Just a couple of points. This particular program, Klck, always produces rooted trees. So the claim is not being made here that there's some distant relationship between Japanese and Italian, let's say, but simply that they have to all be in a single tree. What we can see, though, is that I think it is from here, from this node, that we have the Indo-European family. In fact, all and only the Indo-European languages in the sample are dominated by this node, with the exception of Farsi. There's a slight glitch there, which you can read about in the work by Longobardi and others. So this is the kind of thing that we aim to reproduce then, or to produce, using our separate clausal parameters. And I'm sorry about the scrolling problem that I'm having here. This is spoiling the later parts of the talk. Let me just try now to move on. I'll now actually hand over to Jim, who may be able to share with fewer problems than me. So I'll stop sharing, Jim, and you can start, okay?
Great. Right, so hopefully this will work. Yes, there we go. So our first stage, really, in working on this project was to take the parameters that Longobardi's team had previously defined for the extended projection of the noun and to extend these into a separate list, a broadly parallel list for the extended projection of the verb. So that's for the clause. So as Ian said, that gives us around, well, currently 87 clausal parameters. And we're focusing mostly here on the TP domain and the VP domain. We do have 2 or 3 parameters to do with CP, but in general, we've left that aside. So as I say, many of our parameters have parallels to the nominal parameters. Some of these are very close parallels. So for example, Longobardi is all identified parameter grammaticalized person. And we have identified that same parameter. However, we have taken the further stage of splitting this up into 2 parameters. So our claim here is that we can view person grammaticalized within the nominal as separate from person grammaticalized within the clause. The reason we do this is that we believe that in certain cases there isn't actually strong evidence that person is actually grammaticalized in the clause, even though it may appear in the normal. You can also see this with gender. So this is the grammaticalized gender parameters where we've done the same thing. We see this in English, so it's clear that English does grammaticalize gender within nominals. So for example, the distinction between the reflexive pronouns himself and herself. But we don't actually see anything like gender agreement on the verb or anything in English, suggesting that maybe we actually want to give English a negative setting of the parameter for grammaticalized gender as far as the clause is concerned. Another set of parallels, so Longobardi's team had this parameter MP over D, which is basically concerned with the ordering of the determiner in relation to the rest of the noun phrase. So a positive setting of that is where the determiner follows the MP, and a negative setting is where D precedes the MP. So contrasting languages like English from languages like Basque. The obvious parallel here is in the various head complement relations that we see within the clause. Maybe the closest parallel is little VP over T, but we've also got various other head complement order parameters there as well. So TP over C, and so forth, object over verb. A broader set of parallels arise from work by Gianello et al., which many of you will be familiar with, setting out schemata for parameters, general schemata by which specific parameters may then subsequently be determined. And referring to properties like grammaticalization, here understood in a synchronic sense of whether or not a feature is present in the language, checking, spreading, which we'll see examples of on the next slide, and strength, essentially whether a particular feature is a movement trigger or not. So many of the nominal parameters are constructed along these lines, and therefore in order to produce a broad set of parallels, loose parallels with those, we have constructed many of our parameters according to the same schemata. So a set of examples here concerning aspect. So obviously the basic one is aspect in a language or not? Is aspect grammaticalized? If that is the case, then that opens up various other possibilities. So the possibility of strong aspect, which is instantiated where we see movement of the verb to the aspect head position. A diagnostic for that in verb initial languages, VO languages, is that the verb precedes adverbs like completely or well. We also have the possibility of aspect checking. So this is seen, for example, in the French imperfect, where the verb inflects with a particular ending that, as well as marking agreement, also marks a particular aspectual relationship. So that's a verbal inflection or suffix. But we have other ways of marking aspect as well. So one of these is via aspect spread, which is what we see in periphrastic type constructions like the English progressive, which we have analysed as consisting of a particular aspectual auxiliary, in this case to be, accompanied by an inflection on the verb root itself. So the aspect marking marked not just in the higher position higher up in the clause, but also marked lower down on the verb as well. So spreading from the higher position down into the verb itself. A large number of parameters, however, are not derived on those grounds, but rather are adapted from Ian's earlier work on parameter hierarchies. So we see this, for example, with the passive hierarchy in shown on this slide. So this hierarchy basically asks a number of questions, each of which corresponds to a particular parametric setting, and obviously these are arranged hierarchically in relation to each other. So the second parameter, the question for that is only asked if the answer to the first parameter is a yes, and so on and so forth. So Ian identified 5 parameters for his passive hierarchy. We've got rid of one of those for the common purposes, so I think it's number 4 we don't have an equivalent of. But these other 4 parameters are essentially adapted from the passive hierarchy, asking essentially the same questions as was being asked in this earlier approach, although we've given them slightly different names. We've also added even more parameters to account for further salient patterns of variation in the world's languages that we didn't feel were covered either by our parallels to the nominal set or by the parameter hierarchies previously established, particularly patterns identified in wars, but also patterns from other sources. So, for example, in addition to asking, does the language have aspect, we also have parameters asking about specific types of aspect. So, does the language have grammaticalized progressive, for example? And furthermore, we have parameters asking about whether evidentiality is grammaticalized, parameters asking about whether imperatives are checked on the verb, and so on and so forth. So this is just a summary of the categories of parameters we have, and some information on their sources as well. So the first 8 parameters are to do with 5 features, agreement, clitics. As we've seen, that the first 3 in particular, which are grammaticalized person, grammaticalized number, and grammaticalized gender, have very close parallels to those proposed for the nominal. We then also have a large number of parameters asking questions about tense, aspect, mood, evidentiality, and voice. Again, largely paralleling the nominal parameters in that they make use of the parameter schemata as a basis in many cases, as well as other parameters like, for example, that grammaticalized progressive parameter I just mentioned. A group of further parameters to do with auxiliaries and participle agreement. Then our passive parameters based on the passive hierarchy. Our head complement order parameters, which, as well as paralleling the ordering parameter in the nominal, are also related to the parameter hierarchy for roll-up proposed by Ian. various sort of miscellaneous parameters to do with movement and word order, things like WH movement, also EPP related phenomena. Group of parameters based on alignment, based on the ergative hierarchy in Ian's book, originally due to work by Michelle Sheehan, and similarly a hierarchy for ditransitives turned into various ditransitive parameters. Some parameters to do with transitivity marking, causatives and imperatives, some parameters to do with question marking, some parameters to do with negation, and then a small number of miscellaneous parameters, including ones to do with noun incorporation and VP ellipses. Each parameter then, similar to what we saw before, can be valued either positive or negative. However, as again Ian intimated earlier, sometimes the value of a parameter is predictable from that of the other parameters. So, for example, if the setting of the grammaticalized tense parameter is negative, that means necessarily we will not have a grammaticalized past. So that parameter will be negative. We won't have tense checking V, so that parameter will be negative, and so forth. We've also made various assumptions that lead to other implications of a slightly different type. So, for example, we're assuming the head movement constraint, which means if we have a positive value of the strong C parameter, triggering V to C movement, we're also assuming a positive value of the strong tense parameter, so that will be V to C movement. So these parameters, which are predictable from those of other parameters, are notated again as 0 following the earlier practice. If we want to be a bit more specific, we can refine that as 0 plus versus 0 minus. And importantly, 0 values are excluded from the distance calculations using the distance metric that Ian mentioned. In order to investigate the actual values for this parameter, then we put together a questionnaire which has been sent to experts for each of the languages we looked at so far. In general, these experts are native speakers. I think at least 1 or 2 of you are here today, so thank you very much for your help. It's been really appreciated. So the first phase was just to look at 13 languages, and it's the results of this first phase that we'll be reporting today. We're currently in the midst of the second phase, mostly completed now, looking at a further 22 languages, and we're aiming for a total of 42 within the next couple of months. Once we've got our responses from our informants, once we've gone through those and checked those for consistency and so forth, we can then collect the responses in a table, similar, in fact, to table A we saw earlier. So this is just an example of this, the first 18 of our parameters for, I think it's 9 languages. You can see the plus minus notation there, the 0 notation. Having done this, then, we are in a position to start to analyze this data computationally and produce some results. So we'll be reporting, as I said, the results here for the first 13 languages we've looked at. This chart then shows the values of delta, that's the distance value, which, as Ian said, is calculated as the number of identical parameters between a pair of languages divided by the sum of the number of identities and the number of differences, again with 0 values excluded. So we have 13 languages here. So along the top, we've got English, Dutch, Afrikaans, German, Swedish, French, Italian, European Portuguese, Romanian, Slovenian, Serbo-Croatian, Greek, and Finnish. So you'll note that nearly all of these languages are Indo-European languages, Finnish being the only exception. I've just here grayed these areas where we're dealing with the families within Indo-European. So we've got Germanic languages, Romance languages, and a couple of closely related Slavic languages as well as Greek, which obviously does not fall within any other family within Indo-European. So each of these numbers is this value for the distance calculated on the basis of the clausal parameters alone, according to this formula, excluding 0 values. So, for example, the distance between Dutch and Afrikaans is given as 0.26, or the distance between Greek and English as 0.24. Longobardi's team have suggested, according to some analysis they've done, that the value of delta, the distance value, can be used to make predictions about the likelihood of relatedness between two languages. So if the delta value is below 0.2, that suggests the languages are very probably related. Conversely, if the delta value is above 0.4, that suggests the languages aren't related. Any similarities between the two are essentially random. Then for intermediate values between 0.2 and 0.4, there's a diminishing likelihood of relatedness as the distance value increases. So going back to our matrix, and what I've done here is highlight essentially more closely related languages. So the deeper the shade of red, the more closely related the languages are. So we see this particularly obviously in the case of Slovenian and Serbo-Croatian, which are extremely close, distance of only 0.01, which of course is exactly what we predict, that those languages are close. We also see a pretty close group of distances between the Romance languages. So all of these, apart from Romanian Portuguese, are under 0.2, and even Romanian Portuguese is only 0.22, so not particularly high. And then a looser grouping, but still an apparent grouping between the Germanic languages. So these range from 0.12 between German and Dutch up to 0.30 between German and Swedish. We can note various other interesting properties as well. So we can see that Dutch and particularly German are actually relatively close to the Romance languages. We can also see that Greek here is again particularly close to the Romance family. And Finnish, although it's close to some languages than others, but isn't particularly close to any of them, which is obviously what we would predict with it being the only non-Indo-European language. This version of the matrix, same figures, so in this case, the deeper the shade of blue, the more distantly related the languages are. So we can see that particularly Afrikaans isn't really very close at all to any of the languages outside Germanic. That's also true to a lesser extent of English and Swedish. Slovenian and Serbo-Croatian, although we've seen are very close to each other, are actually quite distant from many other languages, particularly the Germanic languages and Finnish. And Finnish itself, again, tends to be more distant from the other languages, particularly many of the languages within Germanic, as well as the two Slavic languages. So that's very interesting. It does tell us a lot, but we can take things a step further with the application of the phylogenetic software methods that Ian mentioned earlier. Now, different methods produce slightly different trees. So I'm going to show you a number of different trees, which we can compare to some degree. Here to start with, going to present the results of 4 methods which employ the distance matrix given on previous slides. So that is the only input they have. These methods do not have direct input to the parameter values themselves, merely to the distance values. And these methods employ programs within the Billet package. So there's a program called Kitch, a program called Fitch, and a program called Neighbor. The last has 2 different options within it, and I'll report both results. Then following this, I'll show a slightly different method that in fact does operate on the parameter values directly. So this is our tree that emerges from the Kitch program. So a number of interesting things can be observed here. So firstly, as we would predict, Okay, as we would predict, Serbo-Croatian and Slovenian are very close to each other, sharing a node there. We've also got a general grouping between the Germanic languages, with the exception of Afrikaans, which is not included in this grouping. Note that although obviously the traditional model would place English as a West Germanic language with German and Dutch, in fact here we see English as coming out closest to Swedish. Afrikaans then is not only an outlier from Germanic, but is in fact an outlier from the whole of the rest of the sample. Doesn't group with any other language at all. The Romance languages group together with the interesting fact that Greek, however, groups within the Romance family, and Finnish groups outside of all the other families, but in fact is not outside of Indo-European. So we do not see here a separate Indo-European with Finnish divided off, which is perhaps what we would have expected. We have similar results with the UPGMA method, although arguably slightly better, I think. So again, close grouping between Slovenian and Serbo-Croatian. A Germanic grouping here, which in fact this time includes Afrikaans. English and Swedish, again, clustering together with Afrikaans on its own branch. So Afrikaans not grouped with Dutch and German in spite of its ancestry. And then again, a branch for the Romance languages, but again, including Greek. Here, Greek being placed on the same branch as Romanian, and Finnish again, patterning on its own branch, but not patterning apart from Indo-European as a whole. This is the Fitch method. The Fitch method, unlike the previous two methods, produces unrooted trees, hence the difference in the representation here. But overall does produce similar results. So we have a Germanic grouping, it's quite clear there. Within that, Afrikaans, Swedish, with German and Dutch off on their own branch. We then have a sort of general grouping of the rest of Indo-European. Within that, we can see particularly close relationships between the languages in Western Romance, Portuguese, Italian, and French, close relationships between Serbo-Croatian and Slovenian, and then Romanian and Greek also patterning within that. And Finnish, again, off on its own, but we don't actually have, again, we do not have a single Indo-European node appearing here. And this finally is the neighbor joining algorithm, which actually gives very similar results to Fitch in this case. So grouping the Germanic languages, particularly Swedish, Afrikaans, and English, forming their own clade, grouping the rest of the Indo-European languages together, French, Italian, Portuguese on a branch there, Slovenian and Serbo-Croatian there, and Finnish off on its own. Yeah, and then I said we did try another method as well. This is something called parsimony splits, which employs a maximum parsimony method and operates directly on representations of the parameter values. So we've inputted those parameter values for each language as represented as a string, and the aim of the method is to produce a sort of optimal tree requiring the smallest number of changes in parameters to derive a sort of common ancestor. Fairly promising results here, but not brilliant in every respect. So we do have a kind of clear grouping between the Germanic languages as opposed to the others. But as far as the others are concerned, we don't see a clear differentiation into the different families. We don't have a single Indo-European node again. So Slovenian and Serbo-Croatian obviously off by themselves, Finnish at quite a distance from the other languages, and then the others kind of grouping together, clustering together. But there is no single node here that corresponds to the Romance family exclusive of any other languages. So just to summarize what we've just seen, so various points of agreement. We see extreme proximity between Romance and Greek, with Greek typically patterning within Romance, Serbo-Croatian and Slovenian obviously very close, and a close grouping in every case between all the Germanic languages apart from Afrikaans. And all of these points are agreement with the traditional method, with the exception of the placement of Greek. There are, however, certain points of disagreement between the trees. So in one case, the outlier status of Afrikaans. However, this is only found in the Kitch method. The other methods do successfully place Afrikaans within Germanic. And the precise placement of Slovenian Serbo-Croatian moves around a bit. So Kitch has an outlier. The methods tend to have it close to or within the Romance Greek grouping. There are also some other unexpected outcomes, as we've seen the tendency for English and Afrikaans to group closer to Swedish than German and Dutch. Afrikaans, as we've seen, is never placed close to Dutch, in spite of the two being genetically close to each other. And as again, we've seen, there is not a clear-cut distinction emerging between Finnish and Indo-European. So an obvious set of explanations for these patterns is in contact, and I'm going to hand over to Ian to discuss those now.
Okay, Jim, can you stop
Yes.
your screen share then?
Yes.
Yeah. Okay. And I'll try to start mine. So let me try to scroll down. Yeah. Okay, so explanations in terms of contact. So in terms of Afrikaans and Germanic, as we saw, Afrikaans is sometimes grouped with Swedish and English as opposed to Dutch and German. And this, of course, could reflect basically relative deflection in the history of all three of those languages in relation to Dutch and German. English and Swedish, Jim commented on this. It looks as though, at least as a preliminary result, that English is patterning as a North Germanic language. And of course, this has been a theme throughout the history of DIGS, the question of the extent of the Scandinavian English influence on the history of English. There's no doubt that it existed. Recently, as many of you know, there was a claim made by Emmons and Forlund that actually English as a West Germanic essentially died out in the 12th century and was replaced by re-lexified Old Norse. Our results don't necessarily corroborate such an extreme position. They merely corroborate the fact that there's been extensive contact, which is well known. Of course, there's also contact in the history of English with Celtic, which we have no evidence for at the moment because we don't, in this preliminary set of languages, have any Celtic languages, but Welsh and Irish are on their way. There's been contact with French, but that does not show up in any of the phylogenies, reflecting the fact that, again, I think there's a matter of general agreement that the influence of French on English has been primarily lexical rather than structural. The status of Greek in relation to Romance, which comes up absolutely consistently, probably reflects a confluence of typological, historical, and contact factors going back over 2,000 years to early contact between Greek and Latin in southern Italy, Magna Graecia, and contact continuing uninterruptedly to the modern era. We'll come back to this question of length of time of contact in just a moment. Slovenian and Serbo-Croatian, obviously very closely related. Not much to say about that. Actually, in the second set of languages, we have Polish, which has patterned exactly as you would expect, forming a grouping with Slovenian and Serbo-Croatian, but with Slovenian and Serbo-Croatian a group within that group. So exactly what we would want to see. Most of the trees represent a relation between these languages and Romance and Greek, which to some extent, at least in the case of Romanian, may reflect, of course, the Balkan Sprachbund. Slovenian and Serbo-Croatian are fairly consistently closest to Greek and Romanian. Again, we're hoping to get data soon on Bulgarian, which will be very interesting in this connection. But there is also a closer average relationship to the rest of Romance than to Germanic within Indo-European and to Finnish, in fact. So there are possibly other factors at work here, maybe reflecting the fact that Germanic itself as a family has something of an outlier status within Indo-European. Then coming to the question of Finnish, as we saw, it was never represented on a branch separate from Indo-European. And here again, this may be connected to the fact that there is evidence of very extensive contact with Indo-European. There are well-known borrowings from Proto-Germanic in Finnish. Again, we're looking at a couple of millennia of contact potentially. Although, again, as noted, Finnish is actually closer to Romance than to Germanic on average. This may just be a reflection of a sampling bias. One thing that we've discovered, again, with a slightly larger sample of languages that we're working on at the moment, is that if you have just one language from an outlier group, it tends to do strange things. It's when you get more than one language that things start to look clearer. So what we really would need to do to clarify the status of Finnish is get some data on Estonian, for example. On the other hand, the results concerning Finnish do actually converge with the results that the Longobardi group have also obtained with a much larger sample of parameters and languages, including Uralic languages. They, in fact, observe that Finnish and Estonian appear to pattern more closely to Indo-European than they do to the rest of Uralic. And they suggest that this is due to, again, a contact influence going back a couple of millennia. It does seem that the parametric, that this method is giving us some kind of, in a sense, in a negative way, a signal about contact. So generally, the vertical genetic relationships, especially the really solid ones, are coming out quite reliably. We see the Romance languages, we see the very close connection between Serbo-Croatian and Slovenian, between German and Dutch, for example. And it seems that horizontal contact or aerial relationships are coming out when the different methods give us different results. So that in itself could give us a kind of heuristic for distinguishing contact-induced change from straight genetic relationships. A further point that emerges from, again, from the work by Chiolin et al. Is that there seems to be a kind of time window for the contact effects. So in general, their conclusion, again, in relation to their work on nominal parameters, is that the disruption of the syntactic phylogenetic signal by well-documented but relatively recent convergence and borrowing, which they define as in the last 1,000 to 1,500 years, is quite limited. So this is a lower time depth than Dreyer's genus. Remember, Dreyer's 92 definition of a genus is a genetic group roughly comparable in time depth to the subfamilies of Indo-European, i.e. at least 2 millennia. So we could possibly connect this to the typology of parameters that various of us in the Cambridge group have been developing. If mesoparameters define genera, which I think may be a plausible conjecture, then what this suggests is that the contact effects involved that we observe all involve microparameters. Now, of course, one thing we need to do, and in fact, again, are in the process of doing, is to code our 87 parameters as meso, micro, or nano parameters in terms of our taxonomy of parameters. Again, we don't quite have those results ready to show you yet, but we're actively working on this. Given that we've made the distinction between parameters in the extended projection of the verb and parameters in the extended projection of the noun, none of our parameters can be macro parameters as such, because macro parameters, by definition, apply across all categories. Again, coming back to the Greek Romance connection, as we said, the contact goes back about 2,500 years to a very early stage. And of course, there was a close typological and genetic link between Greek and Latin in any case. So it seems plausible in this case that there would be mesoparametric borrowing, essentially, in the history of the convergence and the history of the contact between those languages. Okay, I'll quickly go through some further open questions. One possibility is that different extended projections could reflect contact influence in different ways. It might be that clausal parameters are more susceptible to contact-induced change than nominal ones. And in fact, Krisma and Pintsuk have written on this in connection with showing how English nominal parameters have been much less influenced by North Germanic than English clausal parameters. And indeed, within the clause, it's possible that different domains may reflect contact influence differently. It could be that essentially structurally the higher up a parameter's influence is felt, so in TP or CP, the greater the likelihood of contact influence. This is again something to investigate. Just very quickly moving to future prospects, there is a slightly separate line of research that we've been developing in recent months, which involves applying this method to the older Indo-European languages. We have, in fact, collected data on all of the parameters for Vedic Sanskrit, Hittite, Classical Latin, and Old English. And Marika Melin is in the process of giving us developing the data for Gothic, Middle Welsh, and Old Irish. And Moreno Mitrovic has promised to give us the data on Old Church Slavonic. We have actually an application to expand the method to the other branches of Indo-European, including the more difficult ones such as Tocharian and Classical Armenian, and then essentially try to use this as a basis for syntactic reconstruction of Proto-Indo-European. So maybe we'll be reporting on that at DIGS next year. I hope so. Now here's a very, very preliminary, because there's only 4 languages that we've done this for, very, very preliminary set of delta values for the older Indo-European languages. And we get one interesting result from this, and that is that Hittite tends to come out as a bit of an outlier, certainly in relation to both Sanskrit and Old English, less so in relation to Latin. But of course, this parallels the general consensus among Indo-Europeanists that the Anatolian branch was the first to split off from sort of core Indo-European. Sanskrit, Latin, and Old English are pretty close to one another, which again is a good result. Then looking actually diachronically at delta values, we've also compared Latin with the various Romance languages, and the distance is somewhat greater than the distance between those languages synchronically. So essentially, the Romance languages are parametrically more similar to each other than any of them are to Latin. And again, Longobardi reached exactly this result with the nominal parameters. So it seems that there's been some convergent typological shift amongst the Romance languages in their history. Looking at Old English and Germanic, we get the result that we would expect, that we would all expect, I think, and that is that Old English is significantly more similar to modern German than modern English is, and also to Dutch. The position of present-day English is clearly due to relatively recent developments, again, to some degree contact-induced, and the question of contact with North Germanic and perhaps Celtic is one that we need to properly unravel, as we all know. Okay, so that's pretty much where we are at the moment. As you can see, these are largely interim results, and we hope to be able to report back more fully in the future. But our basic conclusion is that the main interest of this work is that it brings together several different strands. First of all, syntactic theory, that is the sine qua non of all of this, is to be able to define the parameters properly in a theoretically informed fashion. Obviously, the results are relevant for historical linguistics because we're able to actually compute and to quantify historical relations. There are psycholinguistic implications, particularly regarding the implicational relations among parameters, which has an impact on which parameters you really need exposure to in order to get the grammar of your language. That, of course, has in turn will have implications for language change. We're also using computational methods that have been developed elsewhere for phylogenetic tree optimization. Okay, so that's it. Thank you very much.